All right, so we're going to do 4-7 today. It says A, but we're actually going to do all the notes. Remember before when we were talking about inverse functions, and you had to do the horizontal line test to determine if a function was 1-to-1 and would have an inverse. So if you drew a horizontal line and only touched at one point, then it would have an inverse, and you could find its inverse. The same thing is going to happen today. We're going to talk about inverse functions with our 6 trig functions. Okay, so let's think about sine in terms of its graph. So sine starts at 0, 0, comes up to pi over 2, down to pi, down to a minimum at 3 pi over 2, and then back up to 2 pi. And we know that sine is just a repetitive wave. So that means that if we think about going into the negatives here, we would have this coming down to a minimum at negative pi over 2, and then back up to negative pi, and then so on, right? The pattern just continues to repeat over and over and over again. Everybody agree with that? Okay, so now looking at this, is this function 1-to-1? So will it have an inverse? If you were to draw a horizontal line, it would only touch at one point? No, right? The only way to get an inverse is to have this 1-to-1 correspondence. So when you draw that horizontal line, it can only touch at the one point. So because it doesn't, we have to restrict the domain. So to restrict the domain, we're just going to look at negative pi over 2 to pi over 2. So if I only focus on this piece right here, is it now 1-to-1? Yeah, right? If I drew a horizontal line anywhere on that green highlighted piece, this would only touch at one point, therefore I could find the inverse. Now think about this in terms of the unit circle. So we know that it goes up to, 0, 1. Oops, that's positive 1. And down to 0, negative 1. And this is like pi over 2, and this is negative pi over 2. So if we think about just this half of the circle here, doesn't that half of the circle, its coordinates correspond with this piece of this sine wave right here? Right? This is from negative pi over 2 to pi over 2. This is from negative pi over 2 to pi over 2. Alright, and that's just where those curves come from. That's where all those repetitive waves come from. We just graph from the unit circle, those points from the unit circle. Alright, so if you define a new domain of values, right, if you restrict that domain, then we can find the inverse. Going on with this inverse idea, normally before, if I was going to talk about the inverse of x, I would write like x to the negative 1. Right? And that would mean the inverse of x. So if you saw sine to the negative 1 of x, then that would mean the inverse of sine. However, we don't use sine to the negative 1. We use arc sine. Okay? So when you see this arc in front of any of the trig functions, that just means the inverse of that function. So it's read as y is the angle whose sine is x. So anytime you see arc in front of anything, it means you're looking for an angle. Okay, that's really important to understand. So anytime you see that word arc, you're looking for an angle. So now what we're going to do is we're going to use hopefully our brain, but maybe you need the unit circle. I don't know where you're at, okay? So try to figure that out. If you need your unit circle out, go ahead and get it out because we're going to work with it a lot today. You want to ask yourself, where is sine 1/2? So what angle are we at when sine is 1/2? Now remember, sine can only be from negative pi over 2 to pi over 2. So it has to be in quadrants 1 or 4. Okay, so think in your mind, where is sine 1/2? At sine is 1/2 at 60 degrees? 30 degrees. And all of our answers we're going to give in radians. So instead of 30, we're going to write pi over 6. Okay? So this means where is sine of 1/2? Okay? You're looking for an angle. Okay, so now look at B. Where is sine negative root 3 over 2? Now, this occurs in 2 places, but remember, you have to choose within quadrants 1 or 4. So because it's negative, it has to be in quadrant 4, right? So where is sine negative root 3 over 2?
300.
Okay, instead of 300 degrees, let's have a radian value. So, okay, 5 pi over 3. Now, is 5 pi over 3 between negative pi over 2 and pi over 2? Because 5 pi over 3 isn't here, right? 5 pi over 3 is over here, and we're only looking at this piece. So I can change this 5 pi over 3 to be represented within this range of values. How do I do it? Just subtract 2 pi, right? So if I subtract 2 pi, that gives me negative pi over 3, and that's the correct answer. Okay, so not only does it have to be in quadrant 4, but it also has to be between negative pi over 2 and pi over 2. So looking at the rest of these, anytime you see an arc, cosine, arc tangent, whatever, arc anything, it is y is the angle whose, whatever, fill in the blank, tangent, cotangent, is x. So the key here is you're looking for an angle. Any questions so far? Alright, so there are other restrictions, and you have to memorize these. So everything that goes in here, we're going to memorize. Now, I don't know if you've already started your note card for the final exam. Have you even thought about a note card for the final exam? I mean, maybe we should start there. You can use a 3x5. They're up here if you need them. This is something I would put on there. Okay? So this is something you don't want to forget. It's super important. We've talked about sine, but let's write it here so it's all in one place. So the arc sine and the arc cosecant, okay, because they're reciprocal functions, are the same restriction. So they're from negative pi over 2 to pi over 2. Tangent also goes along with those, except, remember, tangent is undefined at negative pi over 2 and pi over 2. So it's not included within that domain. Okay, so that's the one we talked about. And then just kind of adding cosecant and tangent with it. So that means that these are only in quadrants 1 and 4. That's it. Okay? Now the other set are cosine and arc secant. Those are defined from 0 to pi. Same idea with arc cotangent that goes with these, except cotangent is undefined at 0 and pi. So those are not included within its domain. Questions? Okay, so these you have to memorize. So that means that cosine, secant, cotangent, those we're only going to talk about quadrants 1 and 2 because that's from 0 to pi. Okay? Alright, so going back to this idea of the unit circle and thinking about those domain restrictions, it says use the unit circle to evaluate. Well, we know that we have to pay attention to the restriction. So when you're talking about cosine, I'm only thinking about quadrants 1 and 2. So within quadrants 1 and 2, what angle is the answer for arc cosine of -1? So where is cosine -1? at pi, and that is within the restriction, so pi is our answer. Now for B, arc secant of 2, I don't want to think about secant. It's confusing to me. So instead, I'm going to change this to cosine. So I know that I can use the reciprocal function and I can evaluate it the same way. So where is cosine a half? 60, but we can't use degrees, we gotta use radians, so pi over 3. And that's definitely within our domain, which is from 0 to pi. Okay? Arc tangent, now shifting gears into tangent, tangent has to be defined only in quadrants 1 and 4. So where is tangent 1? At pi over 4. Okay, pretty easy, just thinking about the unit circle. Sometimes we're going to be given a value like in example 4 where it's not in the unit circle values and we have to actually use the calculator to do so. So because we're always giving our answer in radians, you have to put your calculator in radian mode. Okay, so just make sure you're in radian mode. Quit out of that. So now, remember before when we were trying to find an angle in the calculator, what button do you have to push? Second, and then whatever trig function you want. So we're going to do second cosine of negative 0.35, so 1.928. Everybody get that? For B, again, it's not a button that we have in the calculator, secant, so we want to change it to the reciprocal. So I have the arc cosine of 1/4. Alright, so we're going to do second cosine of 1/4, or 0.25. And we get 1.318. You go ahead and try C. Did you get 1.528? Okay, everybody comfortable with that? Any questions about the calculator or how to use it? Alright. This next part is a little bit more difficult. Okay, we've got to really think on these. I actually am going to save A until I do E and F. I'm going to show you it the same way. So we're just going to save A. Well, let's go to B. Okay, so first of all, do you remember composite functions? Remember when it said like f of g of x? Remember that? Or f of g, right? And you had to take g and you had to plug it into f, right? You took whatever was listed second and that's actually what you did first. So this is the same idea, except now we just have these inverse functions to deal with, and they're trig values, okay? So it's no big deal. We're going to apply the same idea. Whatever's second or whatever's in the parentheses, we're going to do first. So you have to decide, am I talking about a ratio of sides or am I talking about an angle? So when you see like cosine or sine on the outside, our final answer is going to be a ratio of sides. Okay, it's going to be a value. If you have arc cosine or arc sine, anything with an arc on the outside like you do in C and D, now we're looking for an angle answer. Okay, because remember, anytime you see the arc, that means you're finding an angle. Okay, so you have to know the difference of what type of answer you're looking for. Then you're going to start from the inside. So looking at this piece right here, where is the cosine -1? You have to think about the domain restrictions, so we have to think about between quadrants 1 and 2 only for cosine. Where is cosine -1? Pi. So now I'm going to write cosine of pi, right? Because that middle piece, the set of parentheses, is really just equivalent to pi. Okay, so if you want to put parentheses around it so you know that's what we changed, you can. Okay, so now ask yourself, what's the cosine of pi? -1, and -1 is our answer. Okay? Let's look at C. Okay? What is the sine of pi over 4? So what coordinate are we at pi over 4 for sine? Root 2 over 2. So I'm going to substitute that. So arc sine of, whoops, that was a positive, root 2 over 2. Okay, now we're looking for an angle answer. So where is sine root 2 over 2? In quadrants 1 or 4, because that's where sine is defined. Everybody agree it's pi over 4? Okay. Okay, so now that leads us to why do we keep getting the same thing that we started with, right? Why is this canceling? Think about arc cosine. Doesn't that really mean cosine times cosine negative 1 of negative 1? Right? Like arc cosine and cosine and the negative 1 are the same thing. Well, cosine to the negative 1, couldn't you write that as 1 over cosine? So then it's really like cosine times 1 over cosine. So that's why that canceling is occurring. The problem is if you continue down that pattern, and we just say, well, we can see these cancel and we get 5 pi over 4. 5 pi over 4 isn't within the restriction. So that won't always give you the right answer. So it's better to do it our way, where we're evaluating inside and then working our way out, thinking about the restriction all along. Okay? So now let's do D. What's the sine of 5 pi over 4? Negative root 2 over 2. So arc sine of negative root 2 over 2. Okay? So now we're going to ask ourselves, I'm talking about sine, so I know I have to be within quadrants 1 and 4. Where is sine negative root 2 over 2? 7 pi over 4. Now 7 pi over 4, does that fall within those range of numbers from negative pi over 2 to pi over 2? No, so you have to change it. And to change it, we just subtract 2 pi. So the correct answer here would be negative pi over 4. That's a 2. Okay. Looking at E, and I can go back to A now too, but looking at E or A or F, you'll notice that it's no longer a unit circle value. Okay, so when that happens, we're going to draw a triangle to help us. Okay. Alright, so we're just going to draw a triangle. We have to think about the restrictions. So we're given cotangent of 3 over 8. So cotangent is defined between quadrants 1 and 2. For cotangent to be positive, doesn't it have to be in quadrant 1? If our choice is between 1 and 2, it's got to be in 1 if it's positive. So we're going to draw that triangle in quadrant 1. Cotangent is the adjacent over the opposite. So I'm going to have 3 and 8. Remember, this is theta. Okay. Now, based on that, I can find tangent, right? So this is this information. That's me doing that information first. Just like before we were able to evaluate it first, now we just draw the triangle. Okay, that represents us working with the inside. Now we just find the tangent of that triangle. So isn't tangent just opposite over adjacent? So 8 over 3? Okay, let's look at the next one. So we're given cosine is 3 over 5. So cosine is defined in quadrants 1 and 2. It's positive, so doesn't it have to be in quadrant 1? Okay, so cosine is the adjacent over the hypotenuse. Everybody see the triple that's going on here, a 3, 4, 5 triangle? So I can just kind of cut corners here and write that 4. And then what's the sine of this triangle? 4/5, the opposite over the hypotenuse. Okay. Moving on. Questions? We're going to do it all today. Yeah. Oh, we're going to skip it. It's the same thing as E and F. Okay. G is again Same idea. It's not a unit circle value, so I'm going to have to draw a triangle. Tangent is defined between quadrants 1 and 2. It's given as a negative. So where is it now? I'm not 1 and 2, 1 and 4. It's in 1 and 4. Where does it have to be if it's negative? In 4. So we're going to draw it down here in 4. Tangent is the opposite over the adjacent. I got to think about where the negative goes. Y values are negative in quadrant 4, so it goes with the 2. This one is not a triple. I'd have to do Pythagorean Theorem. So 9 plus 4, take the square root of 13. Okay, so my hypotenuse is the square root of 13. And now I can find the cosine. So cosine is adjacent over the hypotenuse, so 3 over root 13. I have to rationalize this. So 3 root 13 over 13. Everybody comfortable with that? Okay, well sometimes they don't just give us numbers, they throw some variables in too. It's like a treat. Okay? The good news is you can kind of stop thinking about the domain restriction. So it's a little less thinking at the beginning in terms of where do you draw the triangle. Anytime you're given something in terms of x, you have to sketch the triangle in quadrant 1. Every time. Okay? So we're going to start with that triangle in quadrant 1. Alright, now again, secant I'm not really a fan of. So I'm going to change this to the sine of arc cosine of 1 over 2x. I know that cosine is the adjacent over the hypotenuse. At this point I'm looking for sine, so I know I need the opposite side. In order to find it, I'm going to have to do Pythagorean Theorem. Okay? So I'm going to do c squared equals a squared plus b squared. Now when you square this, remember both of those terms have to get squared. So you're going to get 4x squared. And then I'm going to subtract the 1 over. In order to find b squared, what do you have to do? In order to find b, what do you got to do?
Bless you.
Take the square root. So I get b equals the square root of 4x squared minus 1. Now normally, when you're taking the square root, when you're solving, you would get a plus or minus. But because this is in quadrant 1, doesn't it have to be positive? So we're going to assume the positive, so I get the square root of 4x squared minus 1. Can you take the square root of 4x squared minus 1?
Yes.
What do you get? 2x plus 1, 2x minus 1. So you just broke the law with the square root, right? Because you have to have 2 of the same thing to take out 1. So could it be 2x plus 1, 2x minus 1? No. Could it be either one of those? Could it just be 2x minus 1, 2x plus 1? Super tempting, right? Because they're both perfect squares, so it's tempting to do that. But that's super illegal, right? Because you can't take the square root of a sum or a difference. There has to only be multiplication going on. And if you don't believe me, whatever you think the square root is, multiply it by itself. You will not get 4x squared minus 1. Okay? So, now we have our triangle set up. I'm looking for sine. So I'm looking for the opposite over the hypotenuse. So my final answer should be the square root of 4x squared minus 1 over 2x. I mean, you can give all that if you want equals this, or you can, it's okay if you don't. All right, everybody ready for B? Same thing, we're going to draw a triangle. I'm going to draw it up here. It has to be in quadrant 1. Sine is given, so that's opposite over hypotenuse. I have to use the Pythagorean Theorem again. So I'm going to have 3 squared equals x squared plus b squared. So b squared is going to be 9 minus x squared. You have to take the square root. Again, because we're in quadrant 1, we're assuming that positive root only. You cannot take the square root of this number, or this binomial, because it is a sum. And then finally, we have to go ahead and evaluate. So tangent is the opposite over the adjacent, so I'm going to get x over the square root of 9 minus x squared. But can I leave it like this? No, what do you have to do? You have to rationalize it. So we're going to multiply by 9, or the square root of 9 minus x squared. Final answer, x root 9 minus x squared over 9 minus x squared. Now the book will not rationalize it. They'll leave it like this. For me, you will rationalize it. It's one more step, and it's not very hard. Okay, any questions?